Science uses observation and experimentation to develop an understanding of the world around us. In chemistry, we do this using a molecular perspective. We start off by making careful observations that are both reproducible and accurate, and from this we're able to develop some initial ideas in the form of a hypothesis. The key thing about the scientific method is that we take this hypothesis and test it through experimentation. Oftentimes this means that we have to go back and make more observations and refine our hypothesis. But eventually, after a series of experiments, we're able to get an understanding of what it is that is causing the observations that we're seeing. We can then express this understanding as a model. A model is what is commonly known as a scientific theory. One of the most important things about a scientific theory or model is that it has to be testable, and we can then use this model and consider it valid until it's proven wrong by experimentation. When we make a scientific observation, what we're really looking for is change. We want to observe a change and explain it using the models that we've developed. There are two main types of change: physical change and chemical change. During a physical change, the chemical makeup of the substances involved remains the same before and after the physical change. For example, with the car accident, the metal, the glass, the rubber, and the plastic inside the car all remain chemically identical before and after the crash. Their only difference is their physical arrangement around the body of the car. During a chemical change, new substances are formed, and the atoms in the molecules involved rearrange to form new compounds. The metal that was originally used to build the car, shown on the bottom right, has reacted with oxygen and water in the atmosphere to produce rust. Rust, or iron oxide, has a different chemical makeup than the steel that was used to build the car body in the first place. We can also see the difference between a physical change and a chemical change in these two familiar situations. When we boil water, we produce steam, and the molecules in liquid water are identical in composition to those in the vapor phase. In boiling water from its liquid form to its gaseous form, we don't change the chemical makeup. This means that boiling is a physical change. We can easily confirm this by collecting the steam and condensing it back into its liquid form. When we cool down the steam and the gaseous molecules return to the liquid state, we can see that they are chemically identical to the water that we started with, confirming that boiling and condensation are only physical changes. Burning wood in air, on the other hand, is a chemical change. When wood burns, the carbon in the wood reacts with oxygen in the air to make carbon dioxide, a new chemical substance. Burning wood also releases heat and light energy, as well as leaving behind ash. When all this is cooled down, we see that the ash left behind is not of the same form as the wood that we started with, confirming that we had a chemical change. Another interesting observation for these two processes is that when we boil water, we need to put energy into the system, whereas in burning wood, we release energy from the system. This helps to illustrate that with physical and chemical changes, we always have a corresponding change in energy. During the boiling of water, heat energy is transferred into the water molecules to give them enough energy to escape into the gas state. In the burning of wood, chemical energy stored within the wood is released as heat. In observing change, we look at physical properties and chemical properties. Physical properties are like those on your driver's license. They're individual characteristics that you possess. They don't change based on the state you're in. Chemical properties, on the other hand, are like your social behavior. They depend on who you're interacting with as to what behavior you will exhibit. In observing change, we look at physical and chemical properties. Physical properties are like those listed on your driver's license. They don't change depending on the state you're in. They're always the same. Chemical properties, on the other hand, are like the way you act with. Physical properties can be observed without changing the material into a new substance. For example, we can observe the boiling point of water, converting liquid water into gaseous steam, without changing the chemical makeup of the molecules involved. Chemical properties are different in that they describe how a particular chemical behaves when it interacts with others. For example, carbon in wood will react with oxygen to produce carbon dioxide. Chemical properties cannot be observed without undergoing a chemical change and changing the molecular makeup of the molecules involved.